Suppose we have a function f of x and we are asked to find another function, big letter F of x, such that we have the first derivative of this function will be the given function, small letter f of x. How are we going to do this? Now, in this topic on indefinite integrals, we are going to evaluate indefinite integrals involving power functions, involving sum of power functions, polynomial functions, which are the special cases of sum of power functions, and rational functions of the form polynomial divided by x to the r. Going back to the introductory statement, we are asked to find a function big letter f so that if we take its derivative, it will give us the given function small letter f of x. Alternatively, we can rewrite this information as integral of f of x dx is equal to the big letter f of x plus a constant c. And if we are able to find that big letter f, we call that function as an antiderivative of the given function small letter f. In this representation, we call this elongated s as the integral sign. That function small letter f of x is called the integrand. Dx is called the differential symbol. This will tell us as to what variable we are integrating the function. The c here represents a constant of integration. This can be any real number in our case. And we read this integral as integral of f of x dx. Sometimes we read this as the integral of f of x with respect to x. Before we integrate functions, we must have some rules. In particular, we are going to list here two properties and one integration rule. The first one says that if you have an integral of k multiplied by f of x dx, k here is a constant, we can move that constant outside of the integral. Second property says that if you have integral of f plus g with respect to the variable x, and see here we have a sum of two functions, we can integrate this individually. That is, we can integrate the function f of x with respect to x, and after that we add the integral of g of x dx. And the third one is called the power rule for integration. It says that if you have integral of x raised to some power r dx, then this will be equal to x raised to r plus 1 divided by r plus 1 plus the constant c. Take note here that we just have to add 1 to the power r, and whatever is r plus 1, we have to make it the denominator. And also, r here cannot be negative 1. In our first set of examples, we are going to use this formula, the power rule for integration, which says that if you have the integral of x raised to r dx, all you have to do is to add 1 to the power divided by r plus 1 plus a constant. So for letter A, we have integral of x raised to 6 dx. This will be equal to x raised to, the power is 6, so we just have to add 1 to the power divided by 6 plus 1 plus c. We can rewrite this one as x raised to 7 divided by 7 plus a constant c. And that is our final answer. For letter B, we have integral of x raised to minus 5 dx. In here, our power is negative 5. So this will be x raised to minus 5 plus 1 divided by minus 5 plus 1 plus the constant c. Now, minus 5 plus 1 will be negative 4. So this will be x raised to negative 4 divided by negative 4 plus a constant c. And that is our answer. Third, we have the integral of x raised to pi dx. Now here the power is pi, which is a constant actually. So this will be x raised to pi plus 1 divided by pi plus 1 plus a constant c. And we can leave our answer as it is. For the fourth one, we have integral of the cube root of x squared dx. For this example, we need this rule which says that if you have the nth root of x raised to m, you can rewrite this as x raised to m divided by n. So cube root of x squared now will be written as x raised to 2/3. Going back to our fourth example, we are going to rewrite this integral as integral of x raised to 2/3 dx. And in this case, our power is just 2/3. So we just add 1 to 2/3 divided by 2/3 plus 1 plus a constant c. But 2/3 plus 1 is the same as 2/3 plus 1 is 3/3, and this will just be 5 divided by 3. So we can write our final answer as x raised to 5/3 divided by 5/3, but 5 will remain in the denominator and 3 will go up, plus a constant c. Now we just have to take note here that, for example, in the first case, we have integral of x to the 6 dx is actually x raised to 7/7 plus a constant c. Now x raised to 6 here is our small letter f, and x raised to 7/7 is our big letter f. So that means f of x, which is equal to x to the 7/7. And if we are going to find the derivative of the big letter f, this will be equal to 7 times x raised to 6 divided by 7. We can cancel 7. This will give us just the small letter f. Now we can add a c here. That means plus a constant for the f, but this will not actually matter because the derivative of a constant will be 0. So you will still have f prime of x is equal to f of x. Let's consider our second set of examples. For these examples, we are going to use these rules. Integral of k f of x dx is the same as k multiplied by the integral of f of x dx. That means we can move the constant outside of the integral. If f is just a power function, then we will use the power rule for integration, so which is integral of x to the r dx. This will be x raised to r plus 1 divided by r plus 1 plus c. So for letter A, we have integral of 5x cubed dx. Now take note here that the constant is 5. By the first rule here, we can move that 5 outside of the integral, and we will just write the integral as x cubed dx. Now, for this integral of x cubed dx, we are now going to use the power rule because the integrand is a power function. So we will copy the 5 integral of x cubed as in our previous example. We are just going to add 1 to the power. So this power 3 will become 4, and we divide by 4, and we add a constant c. And that is our answer. For letter B, we have integral of x squared plus 4x dx. For this example, we are going to use another rule, which says that if you're integrating sum of two functions, f and g, with respect to the variable x, this will be the same as the integral of the first function, dx, plus the integral of the second function, dx. So we can rewrite this integral as integral of x squared dx plus integral of 4x dx. The first integral is just an integral of a power function, so we just add 1 to the power, so this will be x cubed over 3. We are going to add a c here, but we will add the c only at the last step. That means after integrating both integrals. So this will be plus. Using the first rule, we can move the constant 4 outside. This will be 4 times the integral of x dx. Take note here that the integrand x has a power of 1. So we are going to rewrite this one as x cubed divided by 3 plus 4. We can use the second rule. We just add 1 to the power. So this will be x squared divided by 2 plus a constant c. Finally, we can still divide 4 by 2. So we will rewrite our final answer as x cubed divided by 3 plus 2x squared plus a constant c. Lastly, we have integral of 3x squared minus 5x plus 1 dx. In our second example, we have sum of two functions as our integrand. Now, in our third example, we have 3. We can extend this third rule, so we can get the integral of each term. So this will be integral of 3x squared dx minus integral of 5x dx plus the integral of 1 dx. And as before, we can actually move the constant outside. So this will be 3 integral of x squared dx. 5 can be moved outside. So this will be integral of x dx plus integral of, now 1 is the same as x raised to 0. So for each integral here, we can use the power rule. This will give us 3. Integral of x squared dx will be x cubed over 3 minus 5. Integral of x dx, this will be x squared over 2 plus integral of x raised to 0. That will be x raised to 1 over 1 plus c. We can rewrite our final answer as x cubed minus 5 over 2 x squared plus x plus c. Take note here, we have encountered the case wherein we have integral of 1 dx, and we can simply rewrite this one as integral of dx, and this is just equal to x plus c. For our last example, we have integral of x to the fourth minus 2x squared plus 1 divided by x raised to 4. Let us recall that if you have a plus b plus c, everything divided by d, we can split this into 3 fractions: a divided by d plus b divided by d plus c divided by d. So our integral of x to the fourth minus 2x squared plus 1 divided by x raised to 4 dx can now be rewritten as integral of x to the fourth divided by x to the fourth power minus 2x squared divided by x raised to 4th power plus 1 over x raised to 4 dx. And we can rewrite this further as integral of x to the 4th divided by x to the 4th will be 1 minus, recall the law of exponent, x to the m divided by x to the n. This will be equal to x to the m minus n. So this will be minus 2. Well, the power 2 minus 4 will give us negative 2. So this will be x raised to minus 2 plus. Also, we have a rule that says if you have 1 over x to the n, this will be x raised to minus n. So the third term will be x raised to minus 4 dx. Now, we can rewrite this one as 3 integrals. So this will be integral of 1 dx or just dx minus integral of 2x raised to minus 2 dx plus integral of x raised to minus 4 dx. Now, integral of dx is just x minus the 2 can go outside. So this will be x raised to minus 2 dx plus integral of x raised to minus 4 dx. So for each of these integrals, we are going to use the power rule. So simply add 1 to the power. So minus 2 plus 1 will be minus 1. So this will be x raised to minus 1 divided by minus 1 plus x. Well, the power here is minus 4. Adding 1 to it will give us minus 3. So this will be x raised to minus 3 divided by minus 3 plus a constant. Rewriting this one, we will get x minus and minus will be plus. So this will be plus 2 x raised to minus 1, and this will be minus x minus 3 divided by 3 plus sc. Or we can rewrite this as x plus 2 divided by x using the law of exponents minus 1 over 3x cubed plus the constant c.